You think you're a rational person. You think that because you ask questions, because you look up at the sky sometimes and feel something, because you read articles and watch documentaries and nod along, you are one of the curious ones. One of the awake ones? But here's the question that will follow you through every single minute of what you're about to hear. Why do those who try hardest to understand the universe fall further into the dark the more they learn? Sit with that for a second. Or rather, let it sit with you, because that is what it does. It does not ask permission. It just settles somewhere behind your sternum, cold and quiet, like a stone dropped into still water. There's this thing that happens when you really truly look at the night sky. Not the glance you give it walking to your car, not the polite appreciation you perform when someone points at a full moon. The real look. The one where you tilt your head all the way back, and your neck goes a little stiff, and the cold air moves across the back of your hands, and there's this smell, something like dry grass and distance, and something else you cannot name, and you just stop, and you feel it. That vertiginous, stomach-dropping sensation that the ground beneath your feet is not solid certainty. It is a thin crust of rock floating on fire, spinning through a void so enormous that the word enormous becomes a joke, a tiny, embarrassed little word cowering in front of something it was never built to describe. Every single point of light up there, every single one is a sun. Many of them are bigger than our sun. Many of them have planets. And some of those planets, by the sheer brutal, indifferent mathematics of probability, should have life, should have had billions of years to develop it, nurture it, evolve it into something that looks up at its own night sky and asks the same question we are asking right now. So why is it so quiet? Why do those who try hardest to understand the universe fall further into the dark the more they learn? That silence is not peaceful. That silence is a scream. And the man who understood this better than almost anyone, who sat with the discomfort of not knowing and turned it into the most electrifying intellectual adventure in human history, was a guy from Far Rockaway, Queens, who played bongos, cracked safes at Los Alamos for fun, and once said that if you think you understand quantum mechanics, you do not understand quantum mechanics. His name was Richard Feynman, and what he figured out about the speed of light, about causality, about the deep plumbing of reality itself, is going to do something uncomfortable to the way you see everything. Good. Uncomfortable is where the real thinking starts. Picture this. You're lying on your back in a field. It is summer. Or rather, it is technically summer, but the night air has that edge to it, that slight sharpness that reminds you the planet does not care about your comfort. The grass underneath you is dry, and it makes a faint crackling sound every time you shift your weight. The sky above is ridiculous. There is no other word. It is just ridiculous, with stars layered and dense in a way that city people never see and never quite believe when you try to describe it. The Milky Way is a smear across the whole thing, like someone dragged a wet brush loaded with white paint across a dark canvas, and you're lying there looking up at it, and you feel in your chest, in your actual physical chest, a sensation that is somewhere between awe and panic. Your breathing gets a little shallower, your shoulders pull slightly inward, the back of your neck prickles. You're alone, spectacularly, cosmically alone. And then you think about the light. Because Richard Feynman would think about the light. He could not help it. None of us who have been infected by his way of seeing can help it. That light coming into your eyes right now from those stars, it left its source thousands of years ago. Some of it left before human beings had invented writing, before we had cities, before we had agriculture. That photon traveling across the void for longer than all of recorded human civilization, and it ends its journey on your retina in a field on a Tuesday night while you're lying in dry grass that smells faintly of dust and something floral you cannot identify. And here's the thing that Feynman loved. Here's the thing he would lean forward with that grin on his face and say, that light was traveling at 300 million meters per second the entire time. Not 301 million, not 299 million, exactly the same speed. Always, no matter what, no matter who is measuring it, no matter how fast you're moving. The speed of light in a vacuum is the same for everyone, everywhere, always. That should bother you. It should feel wrong, because it is the strangest fact in all of physics, and it leads directly to the most mind-melting conclusions about the nature of time and space, and why the universe is structured the way it is. And it is the key. the actual key to understanding why the cosmos might be so terrifyingly silent. If you find this channel for the first time right now and your brain is already doing that pleasurable, uncomfortable thing where it stretches into ideas it has never quite reached before, then subscribe. Not because of some algorithm, not because you're supposed to, but because this is a place where we do exactly what Feynman spent his whole life doing. We ask the questions that make people at dinner parties slightly nervous, and we do not stop pulling on the thread until we find something true. Leave a comment too. Tell me, when you look at the night sky, do you feel wonder or do you feel dread? Because the honest answer, the one Feynman would respect, is probably both. Now, back to the silence, because the silence is the conflict. The silence is the thing that should be keeping you up at night, and if it is not, that itself is a problem. Here's the situation we are in, and try to really feel the weight of this. The observable universe, just the part we can see, is about 93 billion light years across. Inside that space, there are roughly 2 trillion galaxies, 2 trillion. Each galaxy contains somewhere between 10 million and 1 trillion stars. Our own Milky Way has somewhere around 250 billion stars. Even if only a tiny fraction of those stars have planets. And we now know from the Kepler Space Telescope data that planets are extraordinarily common. The math points in one direction: life should be everywhere. Enrico Fermi, brilliant physicist, friend and colleague to Feynman's generation of thinkers, sat down at lunch one day and did a version of this calculation on a napkin. Or so the story goes, and asked the question that has haunted science ever since: where is everybody? That is the Fermi paradox, and it is not a comfortable philosophical puzzle you can admire from a safe distance. It is a loaded gun sitting on the table in front of you, and the question of why the gun exists is the same question as why the universe is quiet, and the answer, whichever answer turns out to be true, is either beautiful or catastrophic. There's no version of the answer that is neutral. No, there's not. If we are alone, truly alone in this incomprehensible vastness, then life is either so improbable that its existence here is essentially a miracle, or there's something about the nature of complex life that makes it fragile in ways we have not yet understood. And if we are not alone, if others have been out there developing and growing and reaching upward toward the stars, then something happened to them, something stopped them, something filtered them out. And that filter, that great filter, either lies behind us in our evolutionary past, something we already survived, or it lies ahead of us, waiting. Think about what that means. Sit in that. Let your stomach do what it wants to do with that information. If the filter is ahead of us, then every civilization that reaches roughly our level of technological development eventually destroys itself. Nuclear weapons, engineered pandemics, climate collapse, artificial intelligence running without wisdom. Pick your catastrophe. The point is, something kills civilizations before they can leave their home system, before they can shout into the dark and be heard. And here's where the loss of curiosity becomes not a philosophical nicety but a survival issue, a literal biological civilizational survival issue. Feynman understood this viscerally. He lived through the Manhattan Project. He watched the most brilliant minds in human history build the most terrifying weapon in human history. And he spent the rest of his life insisting that the only antidote to that kind of destructive power was more curiosity, not less. Deeper understanding, not fear of knowledge. Radical honesty about uncertainty, not the comfort of false certainty. When you stop asking questions, when you get too comfortable with the answers you already have, when you let the noise of daily distraction fill the space where wonder used to live, you're not just having a bad intellectual day. You're participating in the slow erosion of the one thing that might actually save us. Your curiosity is not a hobby. It is not a personality trait you can afford to leave dormant. It is the single most important survival technology our species has ever developed, and right now, in this period of history, we are in danger of letting it atrophy from disuse. No. We are not going to let that happen tonight. Why do those who try hardest to understand the universe fall further into the dark the more they learn? Because the more you genuinely learn, the bigger the unknown becomes. And most people, when the unknown gets bigger, flinch. They reach for certainty, they reach for easy answers, they stop looking at the sky, and the sky, indifferent as it is, keeps expanding anyway. Now let us talk about the speed of light. Because this is where Feynman's genius comes in at full force. And this is the key to everything, the key to the silence, the key to the filter, the key to our possible extinction or our possible transcendence. 300 million meters per second. Let us write that in a way you can feel. Light can travel around the Earth 7.5 times in a single second. 7.5 laps around the entire planet, all 7.5 times in 1 second. While you blink, light has crossed a distance that would take you, walking at a comfortable pace, something like 2,000 years to cover. That is not a number. That is a physical sensation. Let it land in your body. Feel it in your gut. Now here's what makes Feynman's eyes light up. Here's what makes him grab your arm because he cannot contain it. Einstein figured out, and then Feynman spent decades deepening and extending, that the speed of light is not just a speed. It is not like the speed of sound or the speed of a car or the speed of a planet orbiting a star. The speed of light is a structural feature of space-time itself. It is the exchange rate between space and time. It is the conversion factor between mass and energy. It is, in the most literal sense possible, the speed of causality, the speed at which one thing can affect another thing. The maximum speed at which information, any causal influence whatsoever, can travel through the universe. And here's where it gets strange. Here's where Feynman would slow down, lean back, get that slightly dangerous look that meant he was about to say something that would crack your comfortable picture of reality right down the middle. If the speed of light is the speed of causality, then the question, why is the speed of light the limit, is actually the question, why does causality have a speed at all? Think about what a universe without that limit would look like. If information could travel instantly, if cause and effect could be connected without any time delay across any distance, then the entire concept of before and after would collapse. There would be no arrow of time in any meaningful sense. Events could cause each other in loops. An effect could precede its cause. Reality, as a coherent, structured, navigable thing, would dissolve. The universe would be a simultaneous, causally tangled mess in which nothing could be distinguished from anything else. There would be no physics. There would be no chemistry. There would be no biology. There would be no Tuesday night in a field under the stars. The speed limit of light is not a constraint on the universe. It is the universe. It is what makes the universe the kind of thing that can have structure, that can have history, that can have us in it asking questions about it. Feynman loved this. He loved it because it is a case where a seeming limitation is actually a generative principle, where the thing that looks like a wall is actually the architecture of the house you're standing in. He spent his career training himself and everyone he ever taught to look at constraints not as obstacles, but as clues. Every law of physics, every conservation law, every speed limit and symmetry is a message from the deep structure of reality about what kind of place this actually is. And this is a mental tool. This is one of the things you can take with you after tonight and use when you encounter a limit in physics, in your own thinking, in your understanding of a problem. Do not fight it first. Understand it first. Ask, what is this limit telling me about the structure of the thing I'm studying? Because often the limit is not the enemy of the answer. The limit is the answer. But now we go deeper, because if light has a speed limit, and that speed limit is finite, and space is as vast as it is, then the universe has built into its own structure a kind of cosmic quarantine. Distances so enormous that even traveling at the maximum possible speed, you could not cross them in any meaningful time. The nearest star to our sun, Proxima Centauri, is 4.2 light years away. 4.2 years of travel at 300 million meters per second. With our fastest current spacecraft, we would need about 70,000 years to get there. 70,000 years. Anatomically modern humans have only been around for about 300,000 years. We would use up nearly a quarter of our entire species' existence just getting to the nearest star. So the galaxy is not just large. It is effectively, for any civilization at our current technological level, unreachable in its totality. The stars are not neighbors. They are not even distant neighbors. They are beings so far apart that the very laws of physics conspire to keep them isolated from each other. Unless you can do something very clever with those laws, and here's your mini-hook. Here's the thing Feynman would drum on the table about. The same physics that creates the speed limit also reveals the loopholes. Not loopholes that break the rules, but loopholes that arise from truly understanding the rules at depth. time dilation. The deeper you understand special relativity, the stranger it gets, and the stranger it gets, the more possibilities open up. If you travel at close to the speed of light, time for you slows down. Not metaphorically, not as a figure of speech, actually, measurably, verifiably slows down. A journey that takes 1,000 years by Earth's clock might take only a few years by the traveler's clock. This has been confirmed in particle accelerators, in atomic clocks on airplanes, in GPS satellites that have to account for relativistic time corrections, or they would give you wrong directions within minutes. Time is not universal. Time is local, time is personal. Your clock is not the same as my clock if we are moving differently relative to each other, and this is not a flaw in our instruments. It is a feature of the universe. Feynman would say, the universe is not obligated to make sense to you. But if you pay enough attention, it starts to make a different kind of sense, a deeper sense, one that is more honest about what reality actually is rather than what you assumed it was. Now here's where the Fermi paradox and the speed of light collide in a way that should genuinely disturb you. And then if you stay with it, liberate you. Why is the universe quiet? We said the answer is either beautiful or catastrophic. Let us look at both with Feynman's tools. The catastrophic answer is the great filter. Here it is in its full unvarnished weight. In the past 50 years, we have gone from no knowledge of planets around other stars to confirmed evidence of over 5,000 exoplanets, with estimates suggesting that there are more planets in the Milky Way than there are stars. Billions upon billions of worlds, and among them a significant number in the habitable zone of their star, where liquid water can exist, where the chemistry of life as we know it becomes plausible. The conditions for life appear to be common, so common that the silence is deafening. The silence is so loud that physicists have given it a name and built an entire research program around trying to explain it. The Great Filter Hypothesis says between the origin of life and a spacefaring civilization, there is at least one step, probably more than one, that is so difficult, so improbable, so deadly, that virtually no civilization makes it through. Most die in the filter. They emerge from the primordial chemistry. They perhaps develop simple cells, maybe complex cells, maybe even multicellular life, maybe even intelligence. And then they hit the filter and they do not come out the other side. If the filter is behind us, if the hard part was getting from chemistry to complex life, or from simple cells to the nucleus, or from sea to land, then we are the lucky ones. We made it through. The silence around us is the sound of everyone else who did not, and our future, though still full of danger, is open. We are the exception. We are the miracle. If the filter is ahead of us, if technological civilizations routinely develop the capacity to destroy themselves before they develop the wisdom not to, then the silence is a warning. It is the universe's way of telling us you are approaching the most dangerous period in your existence. You're reaching the point where your power exceeds your understanding, where your technology outpaces your philosophy, where your ability to destroy vastly exceeds your ability to cooperate. And this is the point where the others did not make it. This is the cliff edge. Feynman would not let you sit in despair about this. No, he would not. He would look at you with that characteristic grin that managed to be both deeply warm and slightly unnerving and say, fine. So there's a filter. The question is not whether the filter exists. The question is, what do we do about it? What tools do we have? What do we know? What can we figure out? And this is where the philosophy of scientific thinking becomes literally a survival skill. Tool number 1, embrace uncertainty, not as a defeat, but as a starting point. Feynman used to say that the first step in not fooling yourself is knowing that you are the easiest person in the world to fool. You, me, all of us, our brains are pattern recognition machines that evolved to find predators in the grass, not to intuitively understand quantum fields or the geometry of space-time. Our intuitions are calibrated for the savannah, not for the cosmos, which means that whenever something in physics seems obviously wrong to your gut, the right response is not to reject the physics. The right response is to ask, what is my gut missing? What assumption am I making that reality is not obligated to share? This is not a passive intellectual posture. This is an active, daily, almost athletic discipline. You have to train yourself to notice when you are reasoning from comfort rather than from evidence. You have to build the muscle of saying, I do not know, and that is the most interesting place to be, rather than I already understand this and reaching for the nearest convenient answer. Tool number 2, understand the difference between a mystery and a problem. A problem has a solution. You apply the right method, you get the answer. A mystery is different. A mystery is a situation where you do not yet have the conceptual framework to even formulate the question correctly. The speed of light was a mystery before Einstein. People knew light had a speed, but they assumed it was like any other speed relative to some medium, some cosmic ether through which it moved. Michelson and Morley did the experiment that should have detected the ether and detected nothing. Silence. Cosmic silence on a smaller scale. And the wrong response to that silence would have been to keep patching the old framework. The right response, Einstein's response, was to ask, what if the framework itself is wrong? What if space and time are not the fixed stage on which physics happens, but are themselves part of the physics? That is the move. That is the Feynman move applied to any domain. When the mystery deepens instead of resolving, do not panic. Do not reach for false certainty. Ask, what assumption am I holding that reality might not be holding with me? Why do those who try hardest to understand the universe fall further into the dark the more they learn? Because they are doing it right, because the darkness is not ignorance. The darkness is the actual size of the real universe becoming visible to you. And if you can stand in that darkness without flinching, if you can keep your eyes open and your curiosity sharp and your willingness to be wrong intact, you're the most dangerous and important kind of person alive, right now. Tool number 3, think in scales. This is something Feynman was extraordinary at. He could move effortlessly from the scale of subatomic particles to the scale of galaxies and back again, and he never lost the thread connecting them. One of the reasons the speed of light is so important is that it connects scales. It is the same in the quantum world as it is in the cosmological world. The electron in your transistor obeys the same speed limit as the light leaving a galaxy 12 billion light-years away. Reality is consistent across its scales. That consistency, that coherence, is not trivial. It is the thing that makes science possible. It is the thing that makes the universe knowable, even if only partially, even if only asymptotically, even if we are always approaching the truth and never quite arriving. And this tool, thinking in scales, is something you can practice. When you feel overwhelmed by the scale of the cosmos, do not try to imagine it all at once. Nobody can, not even Feynman. Instead, build a ladder. Start with what you can touch: the table, the molecules in the table, the atoms, the nucleus, the quarks. Now go the other way: the room, the building, the city, the planet, the solar system, the galaxy. The local group of galaxies, the observable universe. Each step up the ladder changes what the previous step looks like. Each scale reveals something that the adjacent scales obscure. You do not need to hold it all at once. You just need to keep climbing. Now, because you're still here, because you have stayed with this, let me tell you about a woman named Vera, not a famous physicist, not a name in the history books that most people know. Vera was a graduate student in astrophysics in the early 1970s, at a time when the field was not especially welcoming to people who looked like her or asked the kinds of questions she asked. She had been trying to understand the rotation curves of galaxies, the way stars at different distances from the galactic center move, and she kept finding something wrong. The math said that stars far from the center should move slower, the way outer planets in our solar system move slower than inner ones. Gravity falls off with distance. Everyone knew this. Newton, Kepler, obvious. But the stars were not doing that. The stars at the edge of galaxies were moving at almost the same speed as the stars at the center. She checked her instruments, she checked her math, she checked her assumptions. Every time she came back to the same answer. Something is out there, something massive and invisible holding the outer stars in place, keeping them moving faster than they should be. She was not seeing it. No telescope could see it. But the rotation curves were screaming its existence. She sat with that for months. She had mornings where the results made her chest tighten with something between excitement and dread. That specific feeling, tight across the upper chest, slightly difficulty catching a full breath, the sound of her own heartbeat audible in the quiet of the lab. She was looking at evidence of something that should not exist. Something that made up, as we now estimate, about 85% of all the matter in the universe. Something we call dark matter, not because it is dark in a poetic sense, but because it does not interact with light at all. It does not emit it. It does not reflect it. It does not absorb it. It is there, holding galaxies together, shaping the large-scale structure of the cosmos, and we cannot see it with any instrument that detects electromagnetic radiation. Vera did not walk away from that discovery. She did not reach for a comfortable alternative explanation. She sat with the discomfort, with the wrongness, with the silence of her instruments in the face of something real and invisible. And that sitting with it, that refusal to flinch, that is the moment of turning. That is the moment we are all capable of. And it is the moment that matters. If she could stay in that darkness, you can stay in yours. Why do those who try hardest to understand the universe fall further into the dark the more they learn? Because Vera went looking for the structure of galaxies and found that most of the universe is invisible to us. Because every genuine advance in our understanding reveals a larger territory of the unknown. Because the universe is not becoming more comprehensible as we study it. It is becoming more vast and more strange and more magnificent. And the people who can hold that without collapsing, without retreating into false certainty or nihilistic despair, those are the people who push the frontier. Those are the people who matter right now, in this specific, dangerous, extraordinary moment in human history. Here's the thing about quantum mechanics that Feynman spent his whole career wrestling with and laughing about and building into the most precise theory in the history of science: quantum electrodynamics, QED. The theory of how light and matter interact. The theory that describes the behavior of electrons and photons with a precision that, if you were to measure the width of North America with it, would be accurate to within the thickness of a human hair. That level of precision, and at the heart of it, the speed of light. Always the speed of light. The structure of QED is built around the constraint that information cannot travel faster than light, that no physical process can violate causality, that the arrow of time, the thing that makes before and after meaningful, is protected by the speed limit. Feynman developed a way of calculating quantum probabilities called the path integral formulation, and it is gorgeous in the way that only deeply true things are gorgeous. The idea is this: a particle traveling from point A to point B does not take a single path. It takes all possible paths simultaneously, every path that exists. Straight lines, curves, spirals, paths that go backward in time, paths that loop around the sun, every conceivable trajectory. The particle, in a quantum sense, explores all of them at once. And the probabilities of the various outcomes come from how these infinite paths interfere with each other like waves in water, some adding together, some canceling out. The actual observed path, the one you measure when you look, is the result of this cosmic superposition of possibilities. This should sound insane. It should feel wrong in your stomach. That tight, slightly nauseated feeling of a world that does not behave the way you expected. Good, that is the correct response, because it is insane by the standards of everyday intuition, and it is completely, rigorously, experimentally true by the standards of every test we have ever been able to devise. The universe does not care about your intuitions. It cares about the math. But here's the extraordinary thing. Even in this wild quantum world where particles explore all paths simultaneously, the speed of light holds. The structure of space-time, the causal structure that prevents effects from preceding their causes, is preserved even in the quantum realm. It is not an approximation. It is not a simplification for large scales. It is a deep feature of reality that persists all the way down to the smallest scales we can probe. The speed limit is not just fast, it is fundamental, it is woven into the geometry of what exists. And that geometry, that causal structure, is why we exist. Feynman understood this in a way that went beyond equations. He understood it as a kind of wonder. If causality were not preserved, if effects could precede causes, then there is no such thing as history, there is no such thing as learning. There's no such thing as science, because science is built on the idea that past observations constrain future predictions, that causes lead to effects in a reliable and discoverable way. The entire edifice of human knowledge, every book, every experiment, every theory, every discovery, from Vera's rotation curves to Feynman's own path integrals, rests on the foundation that the speed of light enforces. That time has direction, that cause precedes effect, that the universe is knowable. So when you ask, why is the speed of light the limit? You're really asking, why is reality structured in a way that allows knowledge to exist at all? And the answer is because without that structure, nothing we recognize as reality, including us, could exist. That is not a small thing. That is not a footnote. That is the ground under your feet, and it is more solid than any rock because it is not just solid, it is logically necessary. Now here's where we come back to the silence. Here is where we bring it all together. The cosmos is quiet. The filter may be ahead. Our curiosity is the antidote, and it is under threat. The speed of light both imprisons us in our corner of the galaxy and reveals the deep structure that makes thinking about the galaxy possible. What do we do with all of this? Feynman had a practice. It was not a meditation in the soft sense, it was more like a daily recalibration. Every day he would try to find one thing he believed to be true that might be wrong. One assumption he was carrying that he had not recently examined. One comfortable certainty that he was willing to put on the table and probe. Not because he enjoyed doubt for its own sake, but because he understood that unexamined uncertainty is the enemy of discovery. It is the thing that closes the aperture on your mind just when reality is trying to show you something new. You can do this tonight, right now. Pick one thing you're sure of, something about the universe, about yourself, about how the world works, and ask, what would have to be true for me to be wrong about this? Not in a nihilistic way. Not in a way that collapses into everything is uncertain, nothing matters. In a precise, surgical, curious way, what specific evidence would change my mind? If no evidence could change your mind, then what you have is not a belief, it is a wall. Pull down the walls. Build better models instead. The people who pull down walls are the people who find dark matter, who figure out that the universe is expanding, and not just expanding but accelerating, driven by something we call dark energy, which makes up roughly 68% of the energy content of the universe, and which we understand about as well as a medieval peasant understood electricity, which is to say, we know it is there, we can measure its effects, and we have almost no idea what it actually is. 68% of everything, unknown. Dark matter, 27%, unknown. Regular matter, the stuff you're made of, the stars, the planets, the gas clouds, the galaxies we can see, 5%, we are the 5% club. We are the rounding error in the universe's accounting. And instead of finding this humiliating, Feynman found it hilarious and wonderful because it means the adventure is not over. It means the map has almost no territory filled in. It means that for every Vera who sits with the discomfort of an inexplicable rotation curve, there is a discovery of civilizational magnitude waiting on the other side of the discomfort. There is a new category of existence waiting to be named. There is a layer of reality nobody has ever seen yet, not because it is hiding, but because nobody has looked in quite the right way, with quite the right tools and quite the right willingness to be wrong. You have those tools, you have them right now. The willingness to be wrong is a tool. The ability to sit with a mystery instead of papering it over is a tool. The practice of thinking in scales, of moving up and down the ladder of size and time without losing your footing, is a tool. The habit of asking, what assumption am I making that reality is not obligated to share, is a tool. These are not metaphors. They are cognitive technologies, and they are more powerful in the long run than any telescope or particle accelerator because they are the things that make the telescopes and accelerators possible. The universe is 138 billion years old. Give or take, our species has been asking coherent questions about it for maybe a few thousand years. We have had the mathematical tools to really dig into it for maybe 500. We have had the experimental technology to probe its deep structure for maybe 150. In cosmic terms, we just woke up. We are the new ones. We are blinking in the light of our own first genuine understanding, and already we are hitting walls of mystery so profound that our best theories fail to describe them. That is not a crisis. That is an invitation. Why do those who try hardest to understand the universe fall further into the dark the more they learn? Because the universe is bigger than any mind. Because every genuine discovery reveals 10 new mysteries. Because the light we can see is 5% of what exists. And because the ones who go furthest into that dark, the Veras, the Feynmans, the Einsteins, the ones who built their instruments and pointed them at the sky and refused to look away even when the data made no sense. Those are the ones who came back with the things that matter, the things that last, the things that expand the territory of the known and remind us that the unknown is not the enemy. It is the destination, so here you are. You have been lying in that field under the ridiculous star-filled sky, and the grass is still crackling under you, and the air still has that edge, and the Milky Way is still doing its impossible thing above you, and Now, you know things you did not know before. You know that the light entering your eyes left its source thousands of years ago, and that it traveled at the same speed for every single one of those years regardless of anything, because the speed of light is not a rule imposed on the universe, but a feature of the geometry that makes the universe what it is. You know that the silence around you in the cosmic sense is either the sound of a universe where life is a miracle or the sound of a filter that kills civilizations, and you do not yet know which, but you know that the only way to find out is to stay curious, to stay honest, to keep looking. You know that quantum mechanics says particles take all possible paths simultaneously, and that even in that wild probabilistic world, causality is preserved. The arrow of time is real. The speed limit holds. You know that 85% of matter is invisible to us. You know that 68% of the universe's energy content is something we cannot explain. You know that we are the 5%, and that being the 5% means we are the part of the universe that looks back at itself and asks questions, and that this capacity for wonder and self-examination might be the rarest and most precious thing in all of existence. Feynman once said, "I'd rather have questions that can't be answered than answers that can't be questioned." He said it lightly, the way he said most things, with that grin, with the bongos somewhere nearby, with the absolute conviction of someone who had genuinely made peace with not knowing while also genuinely, ferociously, joyfully working to know more every single day. That is the practice. That is the thing to take with you. Not a conclusion, not a destination, a practice. The daily, disciplined, ecstatic practice of looking at the universe with eyes wide enough to see both how much we know and how much we do not, and finding in that gap not despair but the most profound motivation that a human being can have, the chance to be the one who finds the next thing. The chance to be Vera in her lab, tightening breath, racing heart, impossible data on the screen, sitting with the discomfort and coming out the other side with dark matter. The universe is not finished with us. The silence of the cosmos is not a verdict. It is a question, and the fact that you're still here, listening, thinking, feeling the vertigo of all this means you're still asking it. That is enough. That is exactly enough, and it just might be what saves us. CC. That is what Feynman knew, played out in the bones of physics itself. The universe gave us a speed limit, not to cage us, but to give us a cosmos coherent enough to explore. Every constraint is a clue. Every silence is a question. Every moment of genuine curiosity is a vote against the filter, a signal into the dark, a small bright thing moving at exactly 300 million meters per second toward whatever is out there listening. Keep asking. Keep looking. Keep going.